Whether it's the water falling from our skies or the tiny microchips that are going to power our future, we humans have always tried to control the things that matter most. But what happens when those attempts to take charge, well, they spin out of control and create brand new conflicts? That's the big question we're digging into today.
So let's start with the most essential resource there is. What you're looking at is a global map of glacier loss. All those red and orange dots, that's where ice is literally disappearing the fastest. And these glaciers, they're not just ice. They're the planet's water towers, feeding the rivers that billions, and I mean billions of people rely on. So as they shrink, a massive question pops up. What on earth do we do when the tap runs dry?
And look, this isn't some far-off problem for our grandkids. It is happening right now. And the scale of this water crisis, it's almost hard to wrap your head around.
4 billion. Just let that number sink in. According to the top climate scientists at the IPCC and UNESCO, that's how many people. Yeah, half the world's entire population are already dealing with severe water scarcity for at least some part of the year. This isn't some tiny, isolated issue. It's the daily reality for billions of us.
And this map just lays it all out so clearly. The blue areas show where most people live, in the lowlands. And the red and gray bits, those are the mountains they depend on for water. Our entire civilization is basically plumbed into these mountain water towers. But, as we just saw, those towers are melting, which makes our water supply more and more fragile every single day.
Okay, so if our natural water infrastructure is in trouble, a lot of people are turning to technology for an answer. The big question is, can we actually engineer our way out of a drought? So let me introduce you to something called cloud seeding. The idea is actually pretty simple. You take these tiny particles, usually something like silver iodide, and you introduce them into clouds that are already up in the sky. The whole point is to give water vapor something to grab onto, which encourages more rain or snow to fall than what would have happened naturally. It's a very targeted attempt to give local water supplies a little boost.
Now, it is absolutely crucial to understand what cloud seeding is not. People often mix it up with geoengineering, but honestly, they're in completely different universes. Think of it like this. Cloud seeding is like a local tool trying to squeeze a bit more rain out of a storm system passing over your state. Geoengineering, on the other hand, is like trying to install a thermostat for the entire planet by messing with the stratosphere. The difference in scale and in risk is just immense.
But here's the thing. Even this localized tech is not a simple fix, not by a long shot. In fact, it's starting some pretty intense fights on the ground. Let's zoom in on one that's brewing right now in Idaho.
So on one side, you've got the farmers. These are letters from major agricultural groups, and they're arguing that cloud seeding is, and I quote, economically essential. For them, when you're facing down another year of drought, making it snow more up in the mountains is a direct lifeline. It fills the reservoirs they need to irrigate their crops. For them, it is a matter of survival for their farms and their communities.
But on the other side, you've got local residents who are pushing back, and they're pushing back hard. This group of concerned citizens says the data that's being used to prop up the program is, quote, selectively chosen and just plain misleading. They're asking some really tough questions about the science, about the long-term effects on the environment. Basically, they see it as a really risky experiment in their own backyard.
And it's not just them saying this. Their skepticism is actually being backed up by the federal government. A very recent report from the U.S. Government Accountability Office came to a pretty stark conclusion that reliable information on how well cloud seeding works and what its side effects are is simply lacking. So this isn't just a local opinion. This is a finding from one of the government's top watchdogs.
Okay, and this is where it gets really wild. This slide shows the official safety data sheet for one of the flares they use for cloud seeding. And just look at that classification. It is literally listed as a Class 1.4 explosive and a pyrotechnic article. This just hammers home what those citizens are worried about. We're not talking about sprinkling harmless dust here. We're talking about lighting explosive flares in the sky to try and change the weather.
You know, this whole fight in Idaho, it's really a small version of a much, much bigger debate. I mean, if we struggle this much to agree on controlling the weather in one small region, what in the world happens when we start talking about managing the climate for the entire planet?
And that brings us right back to geoengineering.
Yeah, the computer models suggest it could cool the planet, but that list of potential side effects, it is terrifying. We're talking about triggering bizarre weather patterns, causing massive shifts in whole ecosystems, and it would demand a level of global cooperation that, let's be honest, we have never ever achieved. The bottom line is, the consequences of getting this wrong aren't just bad, they could be catastrophic.
So this fundamental conflict, right, the desire to control something versus the massive risk of unintended consequences, that's not just about our environment. Believe it or not, a remarkably similar battle is playing out right now in the world of technology, over a resource that's become just as critical as water, computing power.
And this brings us to the new resource wars. The battleground isn't the sky over Idaho, it's the global supply chain for the world's most advanced AI chips.
At the very center of all this, you have companies like AMD, who are basically caught in a giant geopolitical chess match. To try and follow US rules about selling high-powered tech to China, they actually engineered a special, less powerful version of their top-of-the-line AI chip. The goal here was all about precise control. Let some trade happen, but strictly limit China's ability to train those really powerful, military-grade AI models.
But as this timeline shows, that attempt at surgical control just turned into this chaotic mess. First, the downgraded chip gets made. Then, Washington bans it anyway, citing security concerns. Then, the policy shifts again, and the chip gets approved for sale, but only under super strict licenses and performance caps. It's just a total whiplash, and it shows you how incredibly hard it is to finely tune the flow of something as complex as technology.
And here it is, the great unintended consequence of it all. The Chinese media started calling these restricted US chips sugar-coated bullets. And that's such a powerful metaphor, right? The idea is that relying on these weakened, foreign-controlled chips, even if you can get them, would just create a dependency that would end up crippling China's own tech industry in the long run. So the very attempt to restrict them has become this huge motivator for China to achieve total technological independence.
So whether we are talking about firing flares into clouds or putting restrictions on silicon wafers, we're really driven by the exact same impulse, this deep desire to control very complex systems for our own benefit. But here's the question. Is that control even real, or is it just an illusion?
I mean, we've seen this impulse play out over and over again. We try to direct water supplies in Idaho with snow. We try to manage the pace of technology with export bans. We even think about trying to regulate the planet's thermostat. Each one is this incredibly bold attempt to steer a powerful, complex system in the direction we think is best.
And that leaves us with one final, really challenging question. In trying to solve a drought, do we just end up creating a bitter fight in a community? By trying to slow down a competitor, do we actually just speed up their race to get ahead of us? In our very human quest for control, are we just destined to keep creating ever more complex and unpredictable problems for ourselves?